Bill says she's got the website. Very good. Okay, it's 8 o'clock. We're going to start. I'm going to remind everybody that this webinar is being recorded as video, but no video or audio of the attendees is being recorded. Just the panelists, it's Eric Luiker, and myself, the host. My name is Brad Nickerson. I'm president of the Jemseg Grand Lake Watershed Association. And just as a reminder, our watershed is a big one. It's 3,950 square kilometers, more than 5% of the area of New Brunswick. And Grand Lake at 171 square kilometers is the largest lake, or largest freshwater lake in the Maritimes. And if you're not already a member of our association and you'd like to join us, we welcome you. Memberships are $10 a year, and they support our activities, including the organization and hosting of this webinar. You can contact us at our email address that you hopefully have seen, and we'll send you membership information. I'd like to say we welcome your questions. Eric is going to be speaking, and Eric, if it's okay with you, if we get a question before you're ready for it, I'll read it out when the time comes. Eric's going to have about 3 sections of the presentation, and then he'll invite questions in between. If that's okay, Eric, are you all right?
That sounds good.
Yep. All right. So we're going to have 2 quick live polls now, just to give Eric an idea of what his audience knows and how they can interact and what the background is. So I'm going to launch this poll. There's a question that'll come up, and you just have to click one of the buttons. There's 4 possible answers. You can only click one of them. So I'm going to hit it now, and then about 10, 20 seconds later, I'll give the results. All right, launching the poll. You should be able to answer that question. People could just click one of those answers to the question, which is, do you know what the trophic status of a lake indicates? And then we'll see, once I stopped the poll, everybody should be able to see the results. Hopefully everybody can answer the question. And you should be able to see those results coming in, do you, Eric?
Where do they come in?
Well, maybe you can't see it. I'm the only one perhaps that can see it. It's quite a wide split. The winning response so far is I have no idea. So I'm going to end the poll, and we've been going for almost a minute here. 93% voted. Some people just don't want to answer. There's what the results show us. Can you see it now? Not yet?
I can't myself, no. Oh, there we go. Yep, I see it now.
Yeah, okay. Everybody should be able to see the results, I hope.
So there's 5 people that can tell me how I explained it incorrectly then.
Yeah. Ready for those. We don't know their names. This is an anonymous survey, so they can ask whatever they want. All right, I'm going to stop sharing. And I'm going to stop this poll, and we have one further poll. Let's see if I can find it here. Just pull it up. Here we go. Here it comes. All right. I'm going to send second poll. This is one that Eric would like to know. And I'll let you read the question, and then I'll read it out. What is your biggest concern related to lake water quality? And if the answer is other, then you can type that in the Q&A box, and I will actually read it out so everybody can know what your primary concern about lake water quality is. So there's at least one other. If you wouldn't mind typing your answer or what you think is the worst concern for lake water quality into the Q&A box, we can read it out. I won't be able to see, I don't think. Well, maybe I will be able to tell who it is, but it will be kept anonymous. All right, we've got 39. Okay, with the one other answer that I have is it's a primary concern is sedimentation and increased turbidity. That was one, and then there's a second one that just came in, and if you wouldn't mind, whoever typed that the second one, just typing it into the Q&A box, that would be much appreciated, and I can read it out for everybody. I don't see it yet. I'm going to wait just a few more seconds. We're at 1:30 here, 1:30 seconds, so I don't want to hold people up. Which lake? Okay. Okay. I guess your lake, the lake that you are concerned about, would be, what is your biggest concern related to lake water quality for the lake that you're most concerned about? Okay. There's the other question. Is acid rain still a thing? So the primary concern for this person was acid rain, and I'm going to end the poll and everybody can see the results. Okay, so we had two others. One was acid rain, one was sedimentation, increased turbidity. Ending the poll and sharing the results. And you should be able to see the winner, 54% thought that algal bloom cyanobacteria from excess nutrients is the biggest concern. So this is a result of the second poll. Algal blooms at the top, climate change is second. 11 responses, 27%. All right, so I'm going to just have a brief introduction to Eric Luiker. Just give a little bit of background on Eric's experience, and then we'll turn it over to Eric. So Eric Luiker is an aquatic ecologist and fish biologist. He grew up in Toronto and spent summers at a cottage in Kawarthas, Ontario. Eric obtained his Bachelor of Science degree in marine biology and a Master of Science degree in zoology, both from the University of Guelph. He was an environmental consultant in British Columbia, Newfoundland, and New Brunswick before he joined Environment Canada in 2003. And Eric has worked on lakes and rivers in 8 provinces, including Labrador, and in the high Arctic in Nunavut. He and his family became Grand Lake cottage owners in 2020. I think it was 2020, perhaps 2019, I'm not certain, in the Cumberland Bay area of Grand Lake. And Eric has kindly led our association's volunteer water quality observation program during the summer of 2020. And so Eric, you take it away.
All right. Let me know if the presentation is showing up.
Not yet.
Oh, I have to do something here, don't I? I have to share.
You have to share, yeah.
I can't just do this all by myself. Okay.
Yeah, it worked well last night, so fingers crossed it'll work well tonight. Okay, you have to start PowerPoint if I remember we had the same issue. That's your entire desktop. There we go. That looks better. Then you might want to make it the whole screen. You just want to share the PowerPoint slide rather than the desktop. Perfect. There we go. Okay.
Okay, hopefully everyone can see that. And thank you very much for the introduction, Brad. I have Brad's picture on here. I'm not sure he wanted it there or not, but he's been the spearheader for our association and has done a lot of work in getting not just the water quality program, but a lot of the other aspects of the Grand Lake Association moving forward. And his dedication, enthusiasm has been a big plus. Anyway, the topic I have for today is understanding lake water quality, first steps for Grand Lake. And why I set up the title that way is Brad suggested that several people might not have a lot of background on lake biology or limnology, and that it may not be a bad idea to provide a little bit of a background and then actually talk about our monitoring program itself. So the presentation I have is broken up into 3 components. lake limnology, or the study of freshwater, reviewing some of the basics. Many of you will already know this stuff, so it'll be a review to you. Others, this might be something that you'll learn for the first time. Grand Lake Water Monitoring Program is kind of second component of our discussion here, and I'll talk about how we set it up, who's involved, and what, why, when, and where, and then move on to results from our monitoring program this last summer. I have a very basic lake profile shot here, and I'm not so worried about all the terms in there, but I want you to think about is the different zones that happen in a lake. So the top zone, what we call the aphotic zone, is where light can penetrate into the water column. And where that zone meets the shoreline is the area that you have the littoral zone. So you have macrophytes, algae growing there quite often, a lot of habitat for different types of fish. And then you have the deeper zone in the lake where light is not penetrating, and that's called the aphotic zone, no light, and it really is acting differently than the surface layers of the lake. So there's almost two different systems going on at the same time. When we're looking at lake water quality, one thing that's important to keep in mind is what are the different sources of water coming into your lake, because that will eventually make up the lake water itself. So you have precipitation, you can have runoff on top of the land, but you can also have groundwater seeping into the lake, as well as man-made inputs such as sewage from municipal treatment plants, industrial end of pipes, and also seepage from things like septic tanks that aren't properly set up. So, kind of putting into context some lake limnology into our program, our water quality monitoring program was set up into 3 parameters. One was looking at biophysical parameters of temperature, oxygen, pH, and conductivity, and using vertical profiles. I'll explain those later. Within the lake, also looking at nutrients, and lastly, metals. So I'll go and explain a little bit about each one of these. So bear with me, have some patience, and I'll stop after each section and see if anyone has any questions on those. So we'll start off with the very basics of temperature. I'm pretty sure we all know what temperature is, but some of you may not know kind of all the biology background and how temperature affects different animals and plants. So every plant and animal has its own preferred temperature, meaning it's got a temperature range that it likes to be in, more so than other temperatures. And they also have an upper and lower limit where they cannot survive at those temperatures. So if you look at the graph, and hopefully here or at the table, hopefully you can see my arrow. I have 3 species of fish here: brook trout, yellow perch, and chain pickerel. And you can see that the preferred temperature for each of these is quite different. So brook trout and chain pickerel have a difference of almost 11 degrees Celsius. And on the critical temperature where they cannot survive past, brook trout is at 25 and chain pickerel is at 32. So you can see they're looking to live at different parts of the lake, and their survival is also based on different parts and different temperatures of the lake. At the bottom here, just for fun, I thought I'd show what algae like to do. And you can see here that cyanobacteria and green algae, they do well in warm temperatures. And that's why in the middle of the summer, quite often, you'll see is when we see our algal concerns. So I just have a graph here that shows a bunch of different species. This was taken from a Great Lake composite of fish species in there, and they've put them according to their preferred temperatures. So you could see on the surface in the warmer temperatures here, you have fish that we also like pumpkin seed, smallmouth, or white perch. They don't mind the warmer temperatures, and quite often you'll find them close to the surface or in littoral zone close to the shoreline. Down out here at the bottom, we have fish like lake trout or burbot. They much prefer a colder temperature. So in the summer, you won't see this very often. They'll quite often will be in the deep waters. Showing the algae side of things here. Here's a graph put together by a researcher called Pearl, and what they did is they looked at 4 different types of algae. And on the graph here, you could see on the x-axis is the maximum growth rate, so the rate at which the algae are growing at the best, and here on the x-axis is temperature in degrees Celsius. So the peak of each one of these curves is where the algae are growing the best. So you could see for cyanobacteria, blue-green algae, their optimum temperature is above 30 degrees. And for chlorophytes, it's a little bit below that. But where I'm getting at here is that as temperature warms up, the conditions for algal growth for the chlorophytes and the cyanobacteria improves. For these groups here, undulates and diatoms, their optimum temperature is a little bit colder than that. Okay, moving on to oxygen. One of the things that's important to recognize in a lake is that oxygen mostly comes from the surface. You don't get oxygen generated generally from the deep water. So that's coming from the surface, and reaeration is moving the top surface layer, exposes the water to oxygen from the atmosphere. All animals require a certain minimum level of oxygen, but it's not all the same for all the different animals. And the key component to keep in mind here is plants and algae need carbon dioxide and produce oxygen. And the key there is when they are alive. So we have a few different species here, the same ones I had before. You could see how their minimum oxygen concentrations vary slightly. Some animals will have a higher concentration and some will have a lower. So a chain pickerel here can survive in waters that have a little less oxygen, let's say, than a brook trout. Real concern is when you get into hypoxic or anoxic conditions, which means very low oxygen. And in those areas, you can have lethal effects and large-scale fish kills. And this can happen quite quickly when the oxygen in the water gets down to, let's say, 2 milligrams per liter or less. And this is not uncommon event in areas around the world where they have not kept maintenance on the amount of production in their system. And we can talk about the details of that in a bit. Okay, pH. Someone that mentioned, is acid rain still an issue? pH is a measurement of free hydrogen ions. And in aquatic life, the safe range is between 6.5 and 9, although it's generally in fresh waters, it's more towards 6.5 and let's say a little over 8. And acid rain can lower pH in lakes. So if we look at this little chart here, it's from 0 to 14. That's the range of the pH scale. It's a logarithmic scale. And on one end here, you have very acidic conditions. So let's say it's similar to battery acid. In the high end here, 12, 14 pH, you have ammonia-like conditions, are very basic. Most of our fresh water usually falls in this range here, between about 6 and 8. If you start getting acid rain conditions, this starts to go down. You can get conditions between 4 and 5, which is quite stressful to a lot of animals. I'm showing here a picture on the right. Here's a picture taken in the 1980s of an acid lake. So the low acidity has basically killed everything. So one of the interesting features of an acid lake is it looks quite beautiful when you look at it from above because it's very clear. But once you start looking at it, you actually notice that there's nothing living in it because of the low pH. So here's a lake that, here's a lake on the left that it's had its acid level increased. It's the same lake there, and now it's having a normal set of biological activity. Another parameter that we looked at was conductivity, and conductivity is a measure of the ability of water to pass electric current, and it's measured in microsiemens per centimeter, basically the amount of current that passes over a set distance. And conductivity is linked to ions in water, so the more ions, positive and negative, you have in the water, the greater your conductivity. And generally, if you have clay, silty terrain, we have a little bit of that around Grand Lake. Your conductivity tends to be a bit higher. If you have a granite bedrock style geology in your watershed, quite often your conductivity is a lot lower. There's a few things to look at here, just for comparison. Distilled water, you can see, is very, very low. Freshwater streams, here you'll see our results soon, but we're in the 100, 150 range. I haven't seen any waters up as high as 2,000, but I assume some of the high clay watersheds are like that. And then for those that are trying to, in their mind, figure out what does that mean for salt water, you see here conductivity of plus is what you would see for salt water. All right, is there any questions on those parameters I've covered off so far?
Yes, if anybody has a question, fire away in the Q&A box, and we'll or I'll see both the Q&A and the chat box. So.
Okay, well I'll continue on. If there's a question, Brad, just interrupt me.
Okay, no problem. Yep.
Okay, this is where we start kind of integrating some of those parameters that we were looking at or just describing, and that is we're looking at thermal stratification. So that is caused by difference in temperatures of surface and water bottoms in the lake.
Eric, we have a question from Cheryl Bartlett. She asks, is high conductivity a good thing?
It depends. That's not an easy answer. And let me think about the approach. Generally, if you have higher conductivity, although the buffering capacity is usually linked through alkalinity, if you have higher conductivity, usually your waters are better at buffering pH changes, and it becomes, the water is considered hard water. So let's say if you evaporate in your tea kettle or something like that, if you have very high conductivity, you'll actually see a ring of precipitate of things like calcium. So it's not necessarily, I guess, a bad or good thing. Just it changes the parameters of your water. So soft water is usually considered acidic. Hard water is when you have a lot of material in there.
Okay, we have a question, another question from David Kearns. How does water cloudiness affect the photic depth?
It'll decrease it.
Yeah, okay.
So the more stuff you have in the water will decrease the distance that you can actually see into the water, and also for the light penetrating into the water. So that has an effect on things like algae. So if you have macrophytes growing on the bottom of your shoreline, if all of a sudden your water is cloudy all the time, those macrophytes may not be getting enough light to produce photosynthesis. So it cuts down your light penetration into the water column.
Okay, we have another question from Kim Reeder that says, is sea level rise expected to add salt to a negative degree in this watershed? That would be, I assume, Jemseg Grand Lake watershed.
Hoofta. Now that's a good question. I'll tell you what I know. I don't know if I can answer your question or not, but currently, when you look at the Newcastle hydrometric gauge during the summer when water levels are low, you do see a tidal effect. It's only a few centimeters, but there is a tidal effect. Now that water in Grand Lake is not salt, but previous studies have looked at a salt wedge that does come up into the St. John River, and I think it can get up to as far as Gagetown. Now, whether sea level rise will cause an impact to Grand Lake, I guess probably a modeling study would be able to determine that. We're not that many meters above the ocean there at Grand Lake that a push from the Bay of Fundy might push a salt wedge up that far. I don't know the answer though.
Okay. And then one final comment from Cheryl Bartlett. She read that conductivity was a surrogate for salt content. I'm not sure. Surrogate means that it's basically directly correlated.
Well, conductivity, if you have salt water, if you're measuring conductivity of salt water, you will know it because it goes up very high. So salt water is very conductive. So if you are seeing levels of conductivity that are above, let's say, your background freshwater levels, let's say you're getting into the thousands, you're probably seeing something going on there with salt water. Now, whether it's coming from the ocean or not, who knows? But that's definitely, the two are linked for sure. You know, a high conductivity. Now, mind you, fresh water can have conductivity in the hundreds, and there still is no indication of salt water. So
Okay.
I think we'll see a very high level of conductivity with saltwater intrusion.
Okay, back to you then. I think that's the all. Oh.
Okay, let's move on to thermal stratification. So I talked about how difference in temperature of surface and bottom waters in stratification. So water of different temperatures have different densities. So warmer water is less dense, has a tendency to stay towards the surface. Cold water is more dense and stays towards the bottom. And most of the oceans are at 4 degrees Celsius, and they stay consistent that way all the time. They don't get a lot of environmental effect from above. They're in deep water, and 4 degrees is where water is most dense. So I'll explain this in a second, but if temperature difference is great enough in your lake from top to bottom, it will create something called a thermocline, and the top and bottom don't mix. So I'm going to do a quick review of the different seasons here, and then hopefully they'll help explain a little bit about thermal stratification. So if you look at the spring scenario here, if your top and water bottom, or if your temperature is the same throughout the whole water column, and the density will be the same. So when you have wind movement, that'll help that whole body of water circulate throughout the system here. In the summer scenario, what you have is the surface water is warming, and then in the bottom temperature still saying cool, and this gradient will be great enough that it'll actually create something called a thermocline. So let's go to the next phase here and just have a little look at this. So on the top layer here, number one, what you're seeing is this water is warming up, and the water is becoming less dense. However, the wind is still hitting the surface, so it's mixing around in here. This water here isn't getting the effect of the sun. It's not warming up as quickly, and so what happens is the density of this layer will become different than this layer. And the area in between where the two are separating is called the thermocline. So what you end up here is warm water mixing, lower density. Here, cold water mixing as well. The big difference here, and we'll talk about this in a bit, is what happens with oxygen. So let's keep moving on here. So if you move into the fall, the temperature drops down again, and the top and the bottom of the lake are the same temperature, and you get full mixing. Full mixing of the full water column. And so what you end up having is water chemistry and oxygen levels the same throughout. In the winter, you can have actually something called a reverse thermocline, and that happens when your surface water becomes colder because of the cold winter temperature. than your bottom thermocline. And again, you can have this thermocline separate out your top and bottom layers. So now let's combine some nutrient information, and I'll put that together with our thermal stratification and put together a bit of a story. Nutrients generally are found at quite low levels in lakes that haven't had human impacts. And that also means that algal growth is generally limited. You don't have a lot of excessive growth in those lakes where we haven't had an input. However, nutrients can enter lake from various man-made sources, can come in from sewage treatment facilities, industry. It can come in from runoff from agricultural activities, and we talked about septic tank leakage and so forth. And fertilizer is a very big one as well. And so the increase in nutrients in lake growth. And in my full-time job with Environment Canada, the #1 issue for lakes across Canada is the increase in nutrients. And here on the bottom, I have 2 pictures. The one is of Lake Erie, and this is satellite imagery. And they're able to hone in the spectrum of the camera images to pick up what you see, some green spiral areas here. This is algal growth showing up on a satellite image. Now, I'm not a specialist in this, but they're now getting to the point where they can tell the types of algae that are actually creating that by looking at the color spectrums of the wavelengths of the images. Here on the right side is an image of Lake Winnipeg. Lake Winnipeg is the end of a large watershed that drains a huge part of the prairies where a lot of agricultural and fertilizer and manure application is put into the system. These are all non-point sources, meaning that there's no pipe or anything. It's just running off the control. And Lake Winnipeg has had significant eutrophic conditions for quite a while. And here you can see huge blue-green algae mats on the shoreline. So what are these nutrients that were most, there's 2 of them, nitrogen and phosphorus. Nitrogen, as most people know, is from the atmosphere, or a big chunk of it comes through 78% of our nitrogen comes from there. It's a limiting nutrient for plant growth, meaning that if you add nitrogen, as we do in our fertilizers, it improves plant growth. Generally, without any type of fertilization, the levels of nitrogen are quite low in unimpacted systems, and as is the algal growth, as it is limited by the lack of nutrients. However, as soon as we add nutrients, nitrogen to the system, we get an increase in algal growth. And on the bottom here is a simplified version of the nitrogen cycle. I don't want to get into this too much, except for I just wanted to talk about this nitrification here at the very bottom. These are the forms that quite often you'll see in freshwater. Ammonium doesn't hang around, although this is quite toxic. It breaks down very quickly by bacteria to a nitrite form, which doesn't last long and ends up in nitrate. So quite often the form that you see in fresh water is this nitrate form, which can be food source for algae. And then the other nutrient that is limiting in systems is phosphorus. Phosphorus generally comes from soils or sediments, unlike nitrogen, which comes more from atmospheric sources. In most freshwater systems, phosphorus concentrations are very low, and is quite often the controlling nutrient for aquatic growth. So any slight increase in phosphorus can cause significant algal blooms. And what you see here on the picture on the right is a very famous picture taken of a lake in Northwest Ontario area called Experimental Lakes. And this experiment on this lake was conducted in the late 60s, early 70s, when there was significant issues for eutrophication in Lake Erie. So they're having huge fish kills due to these algal blooms. It was causing real problems. And what was happening is that the companies that were putting out the phosphorus, these large and other companies, they were pushing back, saying that there was no real proof to show that phosphorus was the element of concern. So these researchers, led by David Schindler, in a lake, in this experimental lake area, is an hourglass-shaped lake. They divided the lake into two, and you can see there's a little bit of a barrier here. And on one side of the lake, there was no phosphorus added, and on the other side of the lake, they did add phosphorus. And in just a matter of weeks, algal growth in that lake proliferated very quickly. And this picture itself was used in a correlate to show the how important phosphorus was to algal growth and creating the conditions in Lake Erie. So now we're going to combine our thermal stratification story with our nutrient stories. So nutrients enter the lakes from inland rivers and streams and various sources. So as mentioned, this nutrient will cause algal growth, and depending on the level, you can have significant blooms. However, eventually the algae dies and sinks to the bottom of a water column. So what happens is the bacteria decompose and they start consuming oxygen. So if you remember before, we have this layer at the bottom that's not mixing with the top layer. So what's happening is your oxygen is being consumed in this lower layer. It's called hypoxia. Meanwhile, there's still mixing of oxygen at the top. So all of a sudden you create a scenario where there's cold water at the bottom, but very little oxygen. And it can become a stressful situation for fish and other animals that live down there. So this isn't, unfortunately, this is a little bit blurry, and I apologize for that, but the image makes a good story. So what you see on the left side here is a healthy lake from top to bottom, and the fish are all living at the preferred temperature where they want to be. There might be some migrations up and down, but generally they're happy at the spot where they are. Here on the right is a condition where you're getting hypoxia or low oxygen conditions in your deep water. So all of a sudden you create a conundrum for a lot of these fish. They want to stay in cold water, but no longer is there enough oxygen for them to survive. So some of them just can't escape, and they end up dying, as you can see here, an example. Some will just leave, and then others will kind of stay above the hypolimnion zone or the low oxygen zone and just dip into it if they need to get food or need to get something, and then come back out. So quite often, how big this anoxic or low oxygen zone is, you can have significant fish kills and cause some real problems in your system. Okay, so getting to the end of my limnology discussions here, talk a little bit about trace metals. Metals are naturally occurring, but there's also potential for industrial and other sources to increase these concentrations. The metals can have toxic effects, or they can bioaccumulate. So industrial sources here can release trace metals of various types into the water. They can then be taken into the system by algae and other primary producers, which then can be taken up by smaller fish, bigger fish, and go up the chain. And something like a loon can be eating those fish, and all of a sudden something like loon, they can have issues with things like mercury concentrations that are very high. Okay, so that kind of ends the general discussion on limnology. Does anyone have any questions before we actually move on to our monitoring program?
If I haven't seen any yet, but if there's any come through, I'll let you know, Eric.
Okay, well, hopefully not too many people have dozed off. We'll get to the fun results here. This was the first year of our program, and big kudos to Brad and to Jennifer for putting this water quality program together in the proposal. And we had great support from the Brunswick ETF and the NBALA. And
we have a question that came in from Kim Reeder. Is there any concern about PAH? I don't know what PAH is. Perhaps you do.
I assume you're talking about
polyaromatic.
Polycyclic aromatic hydrocarbons.
Yeah, polyaromatic hydrocarbons.
We did not measure those. I'm not saying that there's no issue in Grand Lake, but there's been no indication to me that those can be a concern. The issue with PAHs is they can get quite expensive to analyze for. But definitely if there is a concern, also PAHs generally are hydrophobic, meaning they don't stay in water very well. If you wanted to get at pHs, usually you look at the sediment, and that's has a tendency to cling to sediments more. I would be very interested if anyone knows of any oil-related issues around Ground Lake, because that's something that could require a little bit more of a specific approach to try to mitigate it.
Okay. Kim says it's hydrophobic. I'm not
That's
sure.
right.
Yeah, okay. Yeah.
Hydrophobic, I mean, it doesn't like to attach to water. So you don't generally find it, if you were to take a water quality sample, you generally don't find a lot of PAHs in the water itself. It's usually attached to sediment.
Got it.
Okay, moving on then. So we decided, because of our lake, that we needed to put together a water monitoring team, and we held a training session in July, and you can see we were at our cottage there in the summer going over the different pieces of equipment, getting used to what, familiar with it, and getting ready for our trips. So we decided to go with a team south and a team north. Because of the size of Grand Lake, we thought if it was just one team, it would take up probably a full day just to sample all the different locations. So we came up with a team south, which was made up of Joy and Rob Thomas and Hazen Hughes and his wonderful boat there. And then on team north, we had Brad Nickerson, Michael Kelly, and myself. And we were kind of located off of my dock. We collected biophysical parameters in a vertical profile manner, meaning that we collected temperature, oxygen, pH, and conductivity at 1 meter intervals, going from the surface all the way to whatever the depth of that specific location was that we're sampling in. And a big thanks go out to NBALA that was able to provide our association with a brand new YSI multimeter, which worked great. It's a great piece of equipment for us to have. And we also measured water clarity using a Secchi disc. For those that don't know what it is, it's as simple as it looks like there in the picture. It's basically a black and white alternating colored disc, and you lower it into the water column, and you see how far into the water column you can still detect the Secchi disc, and then you record that depth. We also collected nutrients. Nutrients were collected from the surface, and we took a suite of nutrients and major ions. You can see all the different things we collected here on the side. These were analyzed at a place called Research Productivity Council in Fredericton. And we also took E. coli samples. And then lastly, similar to nutrients collecting from surface water, just basically filling our water bottles up over the side. We took samples for trace metals. We had 25 metals collected or analyzed for. You can see them here. And again, analyzed at Research Productivity Council. And we had some good discussions about where on such a big system we should actually be sampling. We came to the conclusion that it would be good to have two main deep vertical profile sites. And we have one here at Cumberland Point, which is 25 meters, and one here at Grand Point, which is also approximately 25 meters deep. We were also interested in knowing what's coming into the lake. So we tried to have a few of the sampling sources close to the areas of major input. So we have one sampling site here at Salmon River, which was about 3 meters deep. One here at Newcastle Creek, around 5 meters. Unfortunately, we weren't close enough to the creek as I'd like, but maybe we'll do a bit of adjustment next year. Then here at the connector at Maquapit, 5 meters depth. And then also was interested in knowing what's going out of our system. So we had a site close to the mouth of, or the outlet of the lake into the Jemseg River. Okay, so I'm going to start on the results. We did vertical profiles. So as I mentioned before, measurement at each measure of depth. I'll show results for the two deep stations. The other stations weren't deep enough to get a thermocline. So there's not much of a story there. The surface and the bottom were relatively the same. I'll show you what we got here out of Cumberland Point to start with, and that's where our site was there.
Eric, I have a question, if you don't mind.
Okay.
Apologies for interrupting, but it's from Bonnie Hoyt-Hallett. She asks, for nutrient loading from land, geese have high nitrogen in their feces. What are your thoughts? Can their presence in abundance lead to nitrogen loading?
Absolutely, if it's a big enough quantity, for sure.
Yeah.
I would say the bigger concern, as opposed to a place like Grand Lake where there's a huge volume of water, I would say if you're in a smaller lake, like something like Yoho Lake, or maybe a big pond and there's a lot of geese around, absolutely. In fact, in the high Arctic, in research that we've been doing it the last few years, a big source of nutrients around the lake is geese, and that's a study that they're actually looking at to see what is the impact of that on the lakes.
Thank you.
So vertical profiles in Cumberland Point. So what I've done here is I've combined our results from our 4 sampling periods through the summer. So July, August, September, and October. And each one of these graphs is set up the same way in the sense that on the x-axis is depth, and it starts from the surface, 0, going deeper. And then on the x-axis here is our units of measure. So for dissolved oxygen, the units are milligrams per liter. And then for temperature, it's degrees Celsius, and dissolved oxygen is in gray in all 4 of the graphs, and then temperature is in the brownish orange color here. So you can see starting off in July, we got started a little bit later than I would have liked. So the thermocline was already starting. You can see here, surface is starting to warm up, and the deeper temperatures remain relatively cool. And you start seeing a little bit of change in your dissolved oxygen. If we move to August, all of a sudden you can see a very clear thermocline has formed. So you have a very consistent temperature in the top layers that are affected by the wind. And then you can see this drastic drop off with the density change, and then you get a decrease in temperature. And here is where you see your thermocline. And this is almost textbook. This is exactly as the NBLA diagrams show you, or in most textbooks. So this is pretty consistent. And you also find as dissolved oxygen hits that thermocline, you see a sharp decline in oxygen. because this layer is no longer mixing with that top layer. This top layer is getting re-aerated from the surface. This layer is not getting that oxygen, and that oxygen is being consumed by things that are living there. Well, things that are living there, including the fish and any bacteria or anything that's respiring. So what I've done here is included the CCME guidelines. So that is the Canadian Council of Ministers of the Environment established certain safe guidelines for different parameters. And for temperate waters in non-spawning periods, it's 5.5 milligrams per liter. So you could see here in the summer that we're right on that border and exceed a little bit. Now, that's not a catastrophic event, but something to keep an eye on for future, because if this level or concentration of oxygen starts to drop even further, that's when you can start to get into areas of hypoxia. So something that we want to definitely keep an eye on for the future. In September, the surface temperature started to cool down, and you can see the thermocline is starting to go away. So you're, as opposed to this huge change here, you see a little bit of a hockey stick curve. And then same thing with the dissolved oxygen, you're seeing the top layer and the bottom layer starting to mix a little bit more. And the exceedance of CCME guidelines is only at the very, very bottom. That might even be getting close to into the sediment layer here. And then in October, this was very interesting. Top to bottom, we had the exact same temperature. So we were in the full mix zone here. Must have just occurred. And you can see the oxygen was starting to straighten out, and probably all the little layers hadn't completely mixed yet. So you see a little bit of variation there. Now looking at our other profile site, Grand Point, I'll go through this a little bit quicker, but the story is basically the same. You can see that already in July, the thermocline had started. And then in August, you could actually see a reduction in the oxygen levels here as the thermocline established with the temperature change there. Again, we see a little bit of a few of the deeper sites going below the 5.5 milligram liter CCME guideline. In September, same scenario as before, the temperature starts to even out, and that creates an increase in oxygen. So you can see how it's well above the 5.5 milligram per liter there. So we're back into the safe zone. And again, here in October, we must have been on the day where the full mixing was occurring, because we had same temperature top to bottom, and you can see the evening out of the concentrations for dissolved.
Eric, while you're still on that slide, we have a question from Chris Blair.
Okay.
He asks,
hello, Chris.
Yeah, he asks, he says it's curious that in August, when your temperature is increasing, the DO, dissolved oxygen, does not seem to be falling. It stayed roughly the same. So
was that in the?
And which figure were you referring to, Chris? Was it Grand Point or Cumberland Bay? Cumberland Point. Previous slide, yeah, Cumberland.
So this here, because this area is mixing, that'll stay the same because it's getting re-aerated from the surface. So here you see that big drop off, and there was a little bit of a decline this way. I'm not sure if that'll answer his question, but there was a little bit of a decline. The concern is if this kept going this way. Yeah. So there is probably some mixing going on in this layer, but looking at the temperature, maybe not so much, but, which might be a good sign, meaning maybe that there isn't a lot of oxygen consumption down here to take it all the way to a hypoxic level.
Okay.
Hopefully I answered this question.
Yeah, Chris says thank you.
Okay, so now let's move on to nutrients. I'm starting to drag on here, taking too long. So what we did for nutrients is way back when, Aaron will probably remember this, when we put together an ETF proposal and we determined or came up with some nutrient criteria proposed for the St. John River. And this is a method used by the US EPA. And so what we did is, using this method, we came up with 3 categories for our nitrogen, and phosphorus. And these three categories loosely relate to ideal, meaning kind of a oligotrophic or low production system, acceptable or a medium level of production system, and then concern. If you're getting above this level, you may have algal bloom and low oxygen issues. So this criteria we based on data from the St. John River. So it's not 100% compatible with the Grand Lake, but I'm using it now just as a starting point, and I'm hoping that we can, with more data and more looking around a little bit more as to what different lake associations and governments have used, I'll try to customize something a little bit more towards Grand Lake. But I think this is a good starting point, and it's not too far off from others. So here at the bottom, you can see the results. These are our 6 sampling sites. So kind of starting from the top of the most northern part, Salmon River, down to the Maquapit. So we have nitrogen and phosphorus. And then these are the actual concentrations of the average concentrations through the 4 sampling periods. And I've given them a color code based on how they were up here. So green is ideal, yellow is acceptable, and then red is in the concern range. So
question, sorry, Eric, there's a question from Bonnie Hoyt-Hallett. Would these values be applicable to other lakes?
A big caveat. Like I said, are the actual criteria or our values?
It's a good question. Bonnie, could you type what you mean? Is it the criteria you mean, or would it be the actual values we're seeing? Criteria.
Yeah, so the criteria, again, they weren't based on or designed for lake. They were from river results. So I would use them loosely. So just, I would use them as an indicator of, you know, what ballpark are we in? Are we in the ideal, acceptable, or concern? And hopefully maybe I can work together with the other St. John River Lake associations, because the more, if I have enough lakes with data, I could actually probably create the same, using the same US EPA method, but not using rivers, using lakes. So I might be able to create a criteria for the St. John River watershed lakes.
Very good, thank you.
So I was rambling there a little bit. I was thinking as I was talking, so not a good thing. So also with the data that we collected, we created a trophic state index. And this index was created by a gentleman called Carlson, 1977, a limnologist, and he was trying to find a way of determining the trophic status of a lake. And so that was the introductory question that Brad had in our survey. So the trophic status is really, what is the productivity, or how much productivity is there in your lake system? And productivity generally is related to primary production, meaning how much algal growth is there in the system and how much general biological activity. So the 3 parameters used for that are the total phosphorus, chlorophyll A, and your Secchi disc reading. And the state is similar to our nutrient criteria. So oligotrophic would be similar to our ideal criteria for nutrients. Mesotrophic is a moderate level of biological activity, not an area of concern. Quite often you can have very productive, healthy systems at this level. And eutrophic is a level where you can have a lot of production and also potentially a lot of issues with algae and low oxygen. So generally a state of concern. So I put together, using the formula that Carlson had there for our lake, and I determined it for each one of our sites, starting from the Salmon River here up to the Jemseg River. And we kind of fall almost right in the middle here of a mesotrophic system, pretty good production, not a huge level of concern, but we should maybe start keeping an eye on nutrient input into the lake. One thing that I found very interesting was that Salmon River, Newcastle Creek, Maquapit were all inputs into the lake, and they all have fairly similar values. Cumberland Point and Grand Point were the two main mid-lake sites, and Jemseg River is the outlet from this main body of water, and they all three had similar results. So it's starting to tell me a little bit of a story that we should start looking at some of our input sources and be trying to describe them a little bit better. So what we're thinking of doing for next year is actually going into the rivers just above entering into the lake and seeing what those parameters are. And it might help us tell our own lake story a little bit better. Trace metals. We compared our trace metal results to the CCME guidelines. And as I mentioned before, CCME is the Canadian Council of Ministers' Environment. And they've put extensive work into determining safe concentrations of water quality parameters. I don't put this up here to scare you. It's actually a good news story. Here are metals on the side, and these are the CCME guidelines. Not every parameter has a guideline. For those that do, I compared our results to that. And for this whole suite of trace metals, we only had 2 exceedances, both at Maquapit, one for aluminum and at iron. I've been in enough watersheds around the country to know that this is not an uncommon occurrence. I'm not saying that it's not a problem, but I think it's probably a fairly small one. It's something we can keep an eye on. But the fact that the rest of these all came up well below any levels of concern was a good news story. A lot of them weren't even detectable. All these ND, that means non-detect. So the instrument at the analytical lab couldn't even detect the level for that. So I think that helps us in our future endeavors. Last thing I did is we worked out the water quality index for the lake. This is something probably will continue to improve on. It's kind of the first kick at the can. What the water quality index does is it looks at various parameters that you've selected to be part of your index, and it looks to see how often those parameters or variables are not meeting objectives, the number of times they aren't meeting the objectives, and how big is that non-compliance. Basically getting a sense of, is it way above or way below the limit, or just a little bit. And then they come up with an indicator score of how healthy the system is. So this afternoon, I kind of grinded out some numbers and did an average of, or combined all 6 of our sites and our 11 parameters. I selected basically using the same ones that the province has used for their water quality index. And I came up with a score of 70, which is fair. This includes the Maquapit site. If we took that site out and just included those sites purely in the middle of Grand Lake, this value would be quite a bit higher. So this is kind of the worst case scenario of all of our parameters, or all of our sites. So what it means is we have pretty good water. It's not great. It could be a bit better, but it's definitely quite healthy, and but it leaves us with a couple of spots of concern. So to summarize, for those who have hung in there this length of time and haven't dozed off, temperature profiles are consistent with temperate lakes that we've seen elsewhere. We're seeing the thermocline at the same depths, and oxygen levels decreasing in some of the deep water areas. Something for us to keep an eye on. Not a high level of concern now, but something we want to monitor. Trace metals, we only had 2 CCME exceedances at only 1 site. trophic status for the lake was mesotrophic, need to monitor nutrients closely, and water quality index was fair. And this is my last slide. We're hoping to get feedback from Grand Lake Watershed Association members. There's also quite a few people outside of the association on this talk, so your input would be definitely of interest. We're hoping to continue our water quality monitoring program next year and start looking at potential areas of concern and maybe come up with some nutrient specific projects, trying to figure out where the nutrients are coming from and if they're actually causing a problem. Initiate long-term temperature monitoring program to get a sense of climate changes. And these are things I like to get feedback from our own membership is, you know, are we interested in looking at a fish survey, doing a habitat shoreline survey or a BioBlitz, or then other issues of concern that we may not have brought up. And I thank all those that came and attended our webinar, and hopefully you picked up something new, and I hopefully will pick up something new as well, especially from your feedback, and that might help guide our future initiatives. Definitely, I want to give a big thank you again to Brad for all the work he's done to get this Watershed Association off the ground, for our Crackerjack water quality team in the summer, collecting all the data, and thanks again to financial support both from the NBALA and NBETF. And if anyone is interested, I'll remain available to take any questions.
Yes, we have questions coming in. I'm going to start with the first one. Mike Kelly's asking if there are attendees from East Grand Lakes site. And I don't know the answer, Mike, so I really don't know the attendees' names off the top of my head. But yeah, okay, I'm going to read some of the questions that are coming in. Did the floods of 2018 and 2019 affect water quality? It's from Bruce Kearns.
That's a good question. I don't know the answer to that. And something we should definitely look into, especially when we're talking about water going on top of land that's not regularly flooded. You can get things brought onto land. Generally, it's good for the land itself. It helps fertilize it, but does it change the water quality? That's a good question, and something I'd need to think about a little bit.
I know of wells that were definitely showing E. coli presence after the flooding that were tested.
Actually, the E. coli one is an interesting one, and one that actually at our work with Environment Canada, we've wondered with all that extensive flooding, E. coli spread is definitely a concern. There was areas of New Brunswick that they put a warning out for fiddlehead picking, just because they were exposed to water that did have E. coli levels. So from a bacterial point of view, I would think yes.
Okay, we have a couple of congratulations. Kim Reeder says amazing and thorough. Bonnie Hoyt Hallett says very informative. Definitely learnings for other lakes and cross comparisons, and NBLA is on the right track. Peter Toner asks, what is your take on measuring water quality using cabin protocols? I'll let you answer that one, and then he has a couple of follow-up ones as well.
I'm not sure I fully understand your question, Peter. I know cabin is a benthic macroinvertebrate sampling program, and the idea there is to link the measures that we can take with water quality and that to actually see how it affects the biology of the system. So you're kind of trying to get not just a chemical signal, which we've mostly done in this program here, but trying to get a biological assessment. So, you know, the fact that we have a high parameter, let's say lead or something like that in the water, it might be up. Is it affecting the benthic community or the invertebrates living in that? it may or may not. So the cabin program was really meant to bring a biological component to assessing water quality.
Okay, and he follows up, he asks, is it just too labor intensive for most watershed organizations, too specialized, but are the data better? So it's, I'll let you answer.
Definitely much more comprehensive, because if you can say, looking at your water quality data and your biomonitoring data, including that macroinvertebrates. For those that don't know, macroinvertebrates, they're the bugs, the aquatic insects and other things that live in the stream and lake bottoms, usually under rocks or around rocks. And they're a very good indicator of health of systems. So using that tool, you're able to tell whether your water is healthy, not just from a chemical point of view, but from a biological point of view.
Okay.
But I don't think I answered this, because the question is it worthwhile? I would say if you can do it, it's something that would be very worthwhile, but you may not have to do it every year if you have financial issues. So I'd say being able to do it on a 3-year rotation would be better than not doing it at all.
Okay, we have a question from David Kearns. What impact would you think commercial net fishing in Grand Lake is having on water quality?
On water quality, that's a good question. I don't know much about the commercial fishing in Grand Lake. I'm a fish guy myself, so anybody that's got any information on fish in Grand Lake, keen to hear about it. From my opinion, from what I've seen, I would think the commercial fishing is at a pretty low scale. So my thought would be that the impacts would probably be more on the biological community than on the actual water quality community. So if they're taking out, I assume the targets are probably Gaspereau and eel. I would think the eel numbers probably aren't huge in biomass, but they're a fairly high top predator eel, so they may affect kind of the food web of the system. Gaspereau, there's huge numbers, and those I've heard, if you have large numbers in a small river system, they die off. You can get some change in water quality because of that. But I would think the changes in the main part of the lake would be minimal for actual water quality.
Okay. We have a note from Bruce Jackson. Thanks. Very much appreciated. Very informative. Charlotte says to all participants, panelists, would there be any difference in levels on the Maquapit side of the point versus the Grand Lake side? Would it potentially be closer to the mid levels or Jemseg across the lake? And
can you read that question again, Brad?
yeah, I don't quite follow, Charlotte. You say, would there be any difference in levels on the Maquapit side of the point? I assume she means Grand Point.
So
versus the Grand Lake side. Yeah.
The water quality at the Cumberland Point versus the point at Grand Point, they were very similar. My general feeling is that south of Grand Point is maybe a slightly smaller basin, and I think it warms up maybe a little bit quicker. But there's very little difference in the actual water quality. My feeling is that some of the high parameters that we're getting at the outlet of Maquapit probably aren't even going into the main channel of the lake. My feeling is it might just be heading along the south shore and heading out the Jemseg. But that's something we would probably need some type of current monitoring. I'm not sure how we would do that, but that's my gut feeling.
Okay, Charlotte, I hope that was able to answer your question. Charlotte, Indian Point, the point where Maquapit flows into Grand Lake. That answered it, she says. I think that's where our Maquapit site was right at Scotchtown Road there, when it hits the thoroughfare is where the survey point was.
That's an interesting part of the watershed. It's a very blackish water, kind of different than others, kind of more boggy, and we're getting some high levels, let's say, for phosphorus, and that was something that the Department of Brunswick, Department of Environment in New Brunswick found also for French Lake, that there's some parameters there that were fairly high, including phosphorus. So something I want to investigate a little bit more, maybe on that side of the watershed.
Okay. Sally Brown says, great information, thank you. Harvey Lake. Cheryl Bartlett says Harvey Lake would be interested in a fish survey as well. Stephen Sharp, very informative, important information. Cheryl Bartlett, thank you for this informative webinar. Barb Glanville, what methods are you using to share this information to your Lake Association membership? Well, there's a good question.
I'll pass it on to you, Brad.
Yes, Barb, we're making each of our webinars into a video, and we're posting it on our YouTube channel. That's one primary way that we're doing it. Our plan also is to write a written report, a paper report, well, PDF version of a report that summarizes the findings that Eric's presented here tonight, similar to what Nashwauk Watershed Association has done for their river system. So those are the two ways that we're planning to distribute it. And we have some members who do not have a computer, and nor do they have emails. So we may, if it's not too expensive, we may actually do paper copies of the PDF version of the report and mail it to them, because it is very interesting information. I don't think this information has been available for Grand Lake, at least not to my memory. Okay, so Jennifer McPhail asks, she says, thanks, very good, great presentation. How much variation in water quality would you expect in littoral zones compared to some of the deeper sites that were measured? Or were some sampled sites in littoral zones?
Yeah, that's a good point. One of the things that I've been thinking about, and I've thrown some ideas with Brad, is that if we are getting some seepage out of things like septic fields or from runoff from fields and that would show up in the littoral zone. And our thought next year was to our E. coli sampling. I didn't talk too much about our E. coli program because the values were all very low, and we sampling in the middle of the lake. Where we want to be taking the E. coli is from the perimeter around the edges. And I think next year that that might tell us a little bit of a story if we're finding areas of E. coli. My gut feeling is that there might be some nutrient issues there as well. The other issue could be if there's some site-specific contamination. So let's say there's an old dump site of some sort and there's something right along the shoreline and it's seeping from there. So that would definitely give you a higher concentration of whatever it is you're looking at close to the shore versus in the mid-open lake. The mid-open lake generally mixes everything. So you have everything's kind of blended in, so it's all one big soup. Meanwhile, the littoral zones and the inputs will show a little bit more variation. The other difference in the littoral zone is they warm up quite a bit more. So you might have some more concentrated algal activity. I definitely saw that some of the shoreline areas at our cottage in the summer where we had brief episodes of some cyanobacteria building up.
Okay. Then Matthew Cook says, thank you very much. Great to compare what others are doing on different water systems. I'm not sure where Mike is, or Matthew is from. Mike Kelly says, if you're a new attendee, please type in your name and affiliation. So if you just joined us, or if you haven't already, maybe you could type. First, you need to change the little message box at the bottom to send your chat message to all panelists and attendees. A little blue, in my case, a blue box. And then you can type your name and affiliation if you haven't done so. And a question from Teresa Glanville. Phosphate is used in the water quality index. Phosphate. Is it more common than nitrate or a higher risk?
Phosphate, you can really, for your water quality index, you can use whatever parameters you want. And phosphate is a more accurate form of phosphorus for biological uptake from plants. So it's something that's readily available for them. So if you can, orthophosphate is a good parameter to take. One of the issues with orthophosphate is it's very time sensitive, so you have to get it to your lab quickly. And also it can change state. So the research that I've done as an Environment Canada ecologist is we found that total nitrogen and total phosphorus, as opposed to looking at a component of one of those, is generally a better big picture assessor, because you're getting all the components of that nutrient together. If you're looking at a little bit more site specific, and if you can, using orthophosphate would give you a little bit more accurate concentration of the actual biological available form of phosphorus. Hopefully that wasn't too long-winded.
That's great. Okay, thank you. Sally Alanak says, thank you so much for sharing your knowledge with us this evening. Would love to see such an in-depth study done on the Kennebecasis River. And Gerard Suma, thank you so much. Very much informative. Margot Shepard, thank you for this webinar. Matthew Cook, Sally, you should talk to Ben Whalen. He has a lot of info on the upper Kennebecasis. Charlotte, yes, we already discussed Charlotte's question about Maquapit Lake. Barb Glanville, thank you. I manage our website and I'm just trying to explore more efficient ways to share this important info. Yes, we'll be letting everybody that's attending this evening see the website, or the link for the YouTube webinar, YouTube version of this webinar as soon as it's available. I have all your contact information because you registered. Yes, so Charlotte asks, Maquapit issues. Phosphorus may be coming from Back Lake and the farms along Majorville. Is that a possibility?
Possibly. One thing I wanted to do next year was look at the sub-watershed of the Maquapit and French Lake and see what types of lands come into it, but definitely something is going on there. I wouldn't say it's horrendously high levels, but definitely elevated levels compared to all the other areas that we're testing, and something we definitely want to look at. And it's also very rich ground up there, so just naturally they might be higher levels. That's an area that gets flooded, I would think, quite regularly, and maybe it's just naturally in the system itself.
Yeah, could be. All right, we have a point from Sandy McDonald just directly related to that question. He says, very interesting, thank you. I hope you'll come to Maquapit next summer. I'm assuming he means to do some water sampling there in Maquapit Lake.
Well, we definitely are planning to do one at is it Lakeville Crossing? Is that the name of it?
Lakeville Corner, the
Lakeville
connection,
Corner.
the connection between Maquapit and French Lake.
Yeah, and definitely if I'm not sure how easy it is to get a boat in there, but if there's some interest, we could try to get some sampling done in there as well. That would help us kind of put the full picture together.
Yeah, I don't know about boating there either. There certainly would be some people that know. Kristen Lyons says, Sally, I think some of this work is taking place in your watershed. Worth checking in with your local watershed association. All right, Rick McMillan. Jam Cook, Watershed Landowners Association, thanks for the presentation. Bruce Kearns, thank you for great information. Kristen Lyons, yeah, she's already said that. Charlotte says, thank you, very interesting. Hopefully we will be able to find out what is the cause of the issue at Maquapit Lake check site. And Peter Toner actually gave a link to the Kennebecasis reports. So there are reports, Kennebecasis watershed water quality. And Chris Blair says, thank you. Lee Faulkner, great presentation. Charlotte, small boats can go through to French Lake from Grand Lake. So I'm not sure your boat qualifies as a small boat, Eric, but.
I do have a kayak.
Yeah, this
Yeah,
it could be tough for three of us to be there doing the survey, but
I have a kayak with a hatch in the front, so lots of room for water samples.
okay. Lee Reed says, excellent presentation, very thought-provoking. For our watershed, combines lakes, river, and head pond for the Tobik Narrows Dam. Rick McMillan says it will probably be easy to get a boat anywhere in a couple of days.
Probably,
100 millimeters of rain, I think. Charlotte, motorboats, yeah. And Hazen says, I've been in French Lake with the 50 outboard, 50 horsepower outboard. I guess that's what Hazen's saying there. So I guess the answer is definitely maybe. Your boat might be a little heavy for that. 50 horsepower outboard is going to be smaller than your engine. Yeah, that's the end of the questions.
Well, thank you very much, everyone, for hanging in. And this doesn't have to be the end of the discussion. If you have more ideas or concepts or questions, I'm wanting to learn as well. This is a new lake for me, and hopefully we can improve things as we move forward.
Yeah. Okay. I think we'll turn it off there. It's 9:26 locally, so thanks everybody for coming, and hopefully we'll see you at the next webinar. Thanks again, Eric. That was a great job.
Yeah, thank you.
Okay, talk to you later.